Hi, let us conclude our discussions on sequences and series with the converging geometric series. Let us repeat the formula for a geometric series. We previously derived the geometric series to be equal to A, where A is the value of the first term, 1 minus R to the power of n, where R is our common ratio of our geometric progression, divided by 1 minus R, given that R cannot be equal to 1, because mathematically division by 0 is not allowed. Now, looking at this equation, if we say that R is much larger than 1, or R is much smaller than minus 1, and as n increases towards infinity, this series will increase in value towards infinity, and we say the series is divergent. So what we can say for a divergent series is as n tends to infinity, then Sn will tend to infinity. However, if R is larger than minus 1, or R is less than plus 1, then R will, if I then again look at this equation, R will become smaller as n tends to infinity, and as n tends to infinity, then this term will be much smaller than 1, and we can approximate this geometric series as follows. We can approximate the geometric series by writing A divided by 1 minus R, where we could say R is not allowed to be equal to 1. And we say we can do this because as n tends to infinity, then Sn can be approximated by A divided by 1 minus R. Okay, so because, let us just recap what we said. We said R is less than plus 1. R is within the range of minus 1 to plus 1 without ever being equal to minus 1 or plus 1. So R is larger than minus 1 and R is less than plus 1. As n tends to infinity, this term becomes very much smaller than 1, and we can approximate Sn by A divided by 1 minus R. And we say the series is convergent. Okay, let us look at a converging geometric series with an exam example. The examiner gives us the first two terms of a geometric series. Okay, and he gives us the first two terms as x plus 3 and x squared minus 9. Okay, and the question from the examiner is, calculate the value of x. Calculate the value of x, for which the examiner asks us to calculate the value of x for which the series will converge. Okay. Now, to solve this problem, we first look at the definition of a geometric sequence. And we know a geometric sequence is given by An is equal to R times An minus 1. This is the basic definition of a geometric progression. An is equal to R times An minus 1. Thus we can say that R is equal to An divided by An minus 1, given that An minus 1 is not equal to 0. Okay, so we can then say R, which is the common ratio, is equal to A2 divided by A1, which is given by the examiner as x squared minus 9 divided by x plus 3. We can factorize this expression. We can then say r is equal to x minus 3. Just remember, given that x can never be equal to minus 3, then r is, if we factorize this, the numerator of that equation, that is x minus 3 times x plus 3 over x plus 3. And these two terms cancel out. And we then can say r is equal to x minus 3. If x is not equal to minus 3, that is the proviso. Now, for a geometric series to converge, we just now stated for a geometric series to converge, r must be larger than minus 1 and r must be smaller than plus 1. Thus, we just determined on the previous page that r is equal to x minus 3. So let's replace x minus 3 for r. Therefore, x minus 3 must be less than plus 1 and x minus 3 must be larger than minus 1. Thus, we can say x minus 3 must be larger than minus 1 and x minus 3 must be smaller than plus 1. Therefore, if we solve for x, we can say x must be less than 4 and x must be larger than 2. Right, the second part of the question, the second part of the question is the examiner asked us to calculate the value of x if the sum to infinity is 13. Okay, so we say s to infinity, that is the sum to infinity, which is can be approximated. Now we derive this approximation. We say that as long as r is larger than minus 1 and smaller than plus 1, we can approximate the sum of the series by this expression here. And let's repeat it here. Is approximately equal to a over 1 minus r, and which is given by, now we know what a is. We've been given a by the examiner to be x plus 3, and we calculated r to be equal to x minus 3. So let us put that into this equation. So a is equal to x plus 3 and r is equal to x minus 3. And if we say the sum to infinity is 13, we say then s infinity is equal to 13, then this must be equal to 13. And if we simplify this equation, we say x plus 3 over minus x plus 4, we've just simplified this part of the equation, is equal to 13. And then if I multiply the left side of the equation by minus x plus 4, I must do the same on the right hand side. So I will have x plus 3 is equal to minus 13x plus 52. I can then easily solve for x. I can then say that 14x is equal to 49. Because I add 13x to the right side of the equation, I must do the same to the left hand side, and the same with this term 3. And that implies that if 14x is equal to 49, x is equal to 3.5. So if x has the value of 3.5, the sum to infinity will be 13, and we have solved the problem of the examiner.